Hi, this is the first video of section Feature Improvement with Nonlinear Classification Techniques. In this section, we'll talk about support vector machines, we'll implement KNN on the dataset, we'll review decision tree as predictive model, then we'll make a couple of tricks with dimensionality reduction methods, and then we'll combine all together. In this video, we'll check different SVM kernels, we'll apply a penalty, we will work with polynomial degrees, and the dataset is the same as a wine quality dataset. Let's go to the code. Well, as you can see, I have already written some lines of code. I've imported the libraries and the dataset, and I've cleaned it, and I also have split it for the train and test part, and I check the basic function with logistic regression. The accuracy score is 0.514. So I think that we can make something better. Let's rewrite our fit predict function. Instead of the previous one, we will use support vector machine, which is SVC in Python, and we will tune it. Have a couple of parameters like kernel, use a kernel, and degree is equal to degree. And there is also C, it is penalty, it's equal to penalty. And well, we'll write it here. Kernel is by default linear, and C by default is 1, and degree by default is 3. Okay, let's go further. We can find our kernel. There are 4 main kernel reviews in support vector machine. Well, it's linear, then it's poly, then it's radial one, RBF, and then it's sigmoid. Okay, great. Then we can print accuracy score using kernel and its format kernel and equal to this one. Okay, and then we can just call our fit predict function with a train test y train y test, a standard scalar. Okay, and it's kernel. Okay, let's run it, and now we will receive a result with the different kernels, and we can see that the best one is RBF. It's a radial basis kernel, so let's use it. Now we can proceed to find out the best penalty. So for C in NumPy, log space -1, 3, base equal 2, num equal 4, and we'll print accuracy score using penalty, equal, and this RBF kernel, so its format is C here. Okay, great, and then we will use a fit predict function again, and we will use an RBF kernel, RBF, and the penalty is here. Okay, looks like we got a result. Yeah, we have a better one. This one is much better than without a penalty or with default penalty. Okay, maybe we can try a polynomial kernel. Maybe it will be better than that. Okay, for degree in range to 6, and again print accuracy score using degree with polykernel, and there is a degree here. Okay, and we'll use our fit predict function as well, and we will use a poly, and we'll use 1.5, and degree is equal to degree. Well, looks like anyway the RBF kernel is much better than even the polynomial kernel with a degree 2, 3, 4, 5. And we can find how much better it is. The original score was equal to this one. Okay, and the best score is equal to this one. And improvement is equal to numpy, absolute numpy round times original score minus best score divided by original score. And okay, so, and print overall improvement is percentage, and get add improvement. Okay, and overall improvement is more than 15%. Wow, I mean, it's a huge one. We just spent a couple of minutes and we got this improvement. That's a great result. Well, we learned that SVM kernel is a powerful tool of tuning, and the penalty reduces overfitting and thus increase the quality of model. And we of course can use a polynomial interaction inside SVM, so we don't need polynomial features outside. Well, overall SVM is quite good technique and it can improve your results significantly.